In the previous video, we talked about how to find the general equation of a slope. And we defined it as the limit as h goes to 0 of f of x plus h minus f of x over h. Now this is for any function. That's why this is a general equation for any function. And what I'm going to do is now I'm just going to throw a new term, and we're gonna just introduce some notation, and then I'm gonna provide an example. So this is the we call this the slope function, which is defined by that, or we're gonna call it the derivative function. The derivative function. So we're gonna introduce the new term derivative, which is basically synonymous with slope. So anytime you hear the word derivative, it really just means slope. There's nothing special about the word derivative. There is a financial instrument called derivatives. This is not that. We're just calling, we're going to use the words slope and derivative interchangeably. And also we're going to introduce a new notation. So we're going to call the derivative function by f prime. So this little mark over here. So f prime of x is really, so instead of calling it m, we're going to call it f prime as h goes to 0 of f of x plus h minus f of x over h. Now, our original question, we still haven't answered our original question. And our original question was the following. What is the slope? So in other words, what is f prime of x at x equals 0.25, so when x equals 0.25 for the function, our function, I believe it was 0.25x squared. No, sorry, it was 0.2x squared. It was 0.2x squared. So I'll just go draw a quick graph of this. So, oops. Actually, I'm not going to draw a graph. We had our previous function, which was just a quadratic function, which sort of looked like this. There was a point over here. The x value, the x value was 0.25, and what we wanted, our original question was, what was the slope at that point? So now that we have a definition for the slope, we're going to use this and figure out what the slope is at that point. So so in order to do that, so remember f prime of x is simply the limit as x goes to 0, f of x plus h minus f of x over h. Now, f of x is 0.2x squared. F of x plus h, all you have to do is just sub that in. X plus h squared. And so if I expand that, that's 0.2x squared plus 2xh plus h squared, which is equal to 0.2x squared plus 0.4xh plus 0.2h squared. Sorry, I'm squeezing that in, but I'm just going to write this down right here. So it's the limit as h, this is the limit as h goes to 0. Very important to remember, it's not as x goes to 0, but as h goes to 0. And we'll see why in a second, or how that plays out in a second. So f of x plus h is this expression right here. So I'm just going to write that out here. So 0.2x squared plus 0.4xh plus 0.2h squared minus 0.2x squared all over h. So if you remember from limits, the denominator cannot be 0. Like if as h goes to 0, if the denominator is 0, that's undefined, and so we can't do that. So if you remember from limits, what we need to do is eliminate the h. But before we eliminate the h, we actually notice that a few cancellations happen. So if you observe, there's a 0.2x squared over here and a negative x squared over here. So these will actually just cancel out. So what I'm left with is, actually I'm just going to continue with the black. So it just looks a bit better than the red. So it's going to be 0.4 xh plus 0.2 h squared over h. Okay, and now remember, I need to get rid of the h. So the way I can do that is by factoring out h in the numerator. So I'm going to factor out h in the numerator, and I'm left with 0.4x plus 0.2h all over h. We can notice that the h's will cancel out. And what I'm left with is 0.4x. Now keep in plus 0.2h. Now I'm gonna write something more. Now remember, keep in mind that it's as h goes to 0, not as x goes to 0. So I can plug in 0 for the h, and I don't have to plug in for the x because the limit says it's as h goes to 0. So what I'm left with is 0.4x. So what this is this is simply the slope function. The slope function, or as we also called it, the derivative function. The derivative function. So what this tells us is this tells us the slope at any given point. So now the point that we were interested in, was for x equals 0.25. So for x equals, so in other words, the slope, so f prime, so remember that was the derivative function, for this function at 0.25 is equal to 0.4 times 0.25. All you have to do once you find the derivative function is plug in the x value that you want. So plug in, so say for example for 0.25, we just plug in that and then we'll get the slope. So this is 0.4 times, obviously 0.25 is a quarter, so that's equal to 0.1. So what this means is the slope for f of x, 0.2x squared, at x equals 0.25 is 0.1. Finally, we found the equation of, finally we found the slope at a point for this quadratic equation. And the slope at that point is 0.1. In the next video, I will show you examples of how to do it not just for a quadratic function, but what if we need to do it for, once again, like a linear function, or a cubic function, or a square root function. So in the next video, I'll show you some examples for some of the other types of functions out there.